My name is Megan Quevedo, and these are my thoughts on the effects of penicillin on E. coli. So in the short clip that we watched, the instructor says that the penicillin was able to rupture the E. coli cell because it poked holes in the cell wall, which then caused the cells to lyse. The cell membrane exhibits a selective permeability, and it allows some molecules to enter into the cell while not allowing other things to enter in. And my way of thinking about it and understanding it is that I think of the cell membrane as a gatekeeper. And so the gatekeeper, the cell wall, is able to determine that, yes, you can enter the cell and you can leave the cell, where for other things that are harmful to the cell, it's saying, no, you can't come in. And so it adds this extra layer of protection that prevents the hypotonic environment from entering into cells and causing the cells to lyse. And the penicillin directly targets the cell wall and the peptidoglycan layer. And the bacterial cell has this really strong and rigid structure that prevents the cell from lysing, and it also counteracts the osmotic pressure. But with the penicillin on E. coli specifically, it breaks down that ability for the cell to be able to say, no, you can't come in. It's just the penicillin is stronger on the E. coli cell. The purpose of the cell wall is to protect the cell from the harsh conditions outside of the cell. So bacterial cells contain the peptidoglycan layer. So both gram-positive and gram-negative cells contain a peptidoglycan layer, but the differences between them is that in a gram-positive cell, it has a thick peptidoglycan layer, where the gram-negative has a thinner peptidoglycan layer. But another difference between the gram-positive and the gram-negative cells is that the gram-positive cell has the teichoic acid. And so these prevent different molecules from being able to adhere to the cell and being able to invade it. So it actually protects the cell from bacteria, where the gram-negative doesn't have this teichoic acid. It doesn't have this. It has this thinner cell wall and cell membrane, and it makes it easier, I believe, for bacteria to penetrate gram-negative cells because it doesn't have this extra layer of protection. It has, 3 layers, but it doesn't have these acids that are able to prevent things from adhering. The peptidoglycan layer is a polymer protective grid that goes over the cell membranes, and without that layer, the cells would just rupture and die. And so I just think of it as like this big marshmallow, I guess, on the outside of the cell, and it's protecting it. I think that the penicillin acts better on a gram-negative bacteria because that peptidoglycan layer is so much thinner, as I just mentioned, and it doesn't have as many things to go through. And so even with the penicillin penetrating the E. coli cell, it only has to go through this thin layer, and obviously this is not the size of it, but I just think it's easier for it to do it that way. It's easier to break down the peptidoglycan cell wall, even though the layers of gram-negative are more complex than gram-positive. I just feel that due to that smaller layer of peptidoglycan, that it makes it a lot more permeable to the outside environment and to things such as penicillin. And those are my thoughts on the effects of penicillin on E. coli. I hope you enjoyed this video, and I look forward to learning more from you throughout this session.